This lesson here is going to be taking a look at contextual problems. And remember, when we talk about contextual problems, we're talking about ones that have a real life scenario or a real life example, we may say. Contextual, the word context means that there is some sort of context to it. Now, when there's context to a problem, usually there are some restrictions that are in place. So we can think of them as all sorts, and we'll talk about some of those as we go. But today we're going to be taking a look at how do we write contextual linear inequalities. So when a contextual problem is presented, solutions can often be represented by equations and inequalities. And we've taken a look at equations in the past, and today we're going to be taking a look at inequalities. So when writing a contextual solution, follow the rules. First thing we want to do is define our variables. So make sure that you and anyone that's reading, so namely the teacher often, or someone who is maybe reading your paper, so to speak, can understand what each letter represents. Okay, so we might have something like X is equal to the number of students, and Y is equal to the cost of the party. All right, there's one example. That's just some random example there. It's just saying that X is the number of students, so whatever our value of X is, that's going to be how many students are going to be there, and then Y is going to be the value of the party. The Y is dependent on the X, so the more students, the higher the cost. Less students, less high cost. Okay, depending on what we're doing there. So we could have like number of something, and if you use the number sign, I'm just fine with that. By the way, that is a number sign, not a hashtag. In this case, we're going to say it's number of students, not hashtag of students. For those of you that are social media savvy, I am not, as you may be able to tell. But that means our number, so it's number of students. Don't need a number there. Cost of party would be something like that. It could be profit of sales or profit or sales. It could be cost. There's all sorts of different things that we might represent based on our variables. Maybe we're looking at, we'll take a look at a bunch of different examples and how we represent our X and our Y. Now, you can use any single variable that you want. You can use the letters A through Z. You could use other letters if you really want to. I'm gonna always use X and Y, just because I like X and Y. It's clean, it's crisp. We know which one is our dependent variable, which one's our independent variable. Sometimes it matters, sometimes it doesn't matter. But X and Y are just really clean and crisp, makes it easier to graph as well, especially if we're gonna plug it into Desmos. The second thing we're gonna do is we're gonna state our restrictions on our variables. Okay, so we have to make sure that we do that. Restrictions are, what it means is what solutions are possible. Okay, what solutions are possible? Now this is going to come into our domain and range. So what kinds of X values could we have? What kinds of Y values could we have? So just as, we'll get into domain and range shortly. It's right down here. But it's just kind of saying, if we're talking about number of students, can we have a negative number of students? No, it has to be positive. Okay, so they have to be positive numbers. Can we have a decimal number of students? No, you can't really invite half a person. It's just, even if that person, and now again, this might sound morbid here, but even if that person would be, let's say, missing a limb, they're still considered a full person, right? They're not part of a person. They're still a full person. So we can only have full numbers of people, and they have to be positive. And so that would be one of the restrictions. Okay, and costs would have different restrictions that are on there. So that would be restrictions. So what solutions are possible? Can we have positive numbers, negative numbers? Are they whole numbers? Are they real numbers? And we'll talk about that in just a little bit. Number 3, we need to determine the problem or problems which need a solution. Okay, and based on our problems, okay, so maybe we're looking at cost of the party. Well, that would be one of our problems. We want to figure out an equation to come up with the cost of our party. And so we might get something that looks like, okay, Y is equal to 15x plus 12. There we go. Okay, that would be one of our solution sets. For however many students we have, this will be the cost of the party, and so on and so forth. Okay, or we could have an inequality that goes that would be a part of as well. And I'm not going to draw an inequality here, but maybe Y has to be greater than or equal to X. Okay, so the cost has to be greater than the number of students. That might make a little bit of sense, or maybe not so much sense, but this would be kind of what our solution would be. Okay, so our solution is going to be either an equation or an inequality which can solve the problem. Okay, and so we have to figure out what our problem is, or in the case of a system of inequalities or equations, our problems. That's where the S comes in. And so we might need just one equation, we might need multiple equations, we might need one inequality, we might need multiple inequalities. And so we have to make sure we do that. Now, when we have inequalities, if we want to determine what our symbol is going to be, are we going to have the greater than or less than sign in there? We're going to use some values which are going to be exact to find out what it's equal to, and we'll find some ones that are not exact to determine which way our inequality sign is going to look. So that's what we're going to do there. And now, so that's just representing how we come up with our inequalities.